Hi everyone, thank you for joining. In this video, we're going to solve a challenging number theory question. We are given that x and y are prime numbers, and we want to find x and y such that it would satisfy the given equality. If you like to try it yourself first, pause the video, and then we could go over it together. So let's assume that x is not equal to 3 and y is not equal to 3. Right? So that implies x must be either 1 or 2 in mod 3. Similarly, y must equal to 1 or 2 in mod 3. If x is equal to y in mod 3, that is, let's say x is equal to y is equal to 1 in mod 3, that means the left-hand side would read x cubed minus y to the 5 is equal to 1 cubed minus 1 to the 5, which is equal to 0 in mod 3, right? So in other words, left-hand side is divisible by 3, right? But if we look at right-hand side, so if x is equal to 1, y is equal to 1 in mod 3, on the right-hand side we have x plus y squared, so we have 1 plus 1 squared, which is equal to 4, which is equal to 1 in mod 3, so it is not divisible, right? Now the other scenario is that if x is equal to y, and that's equal to 2 in mod 3. Similarly, left-hand side, we would have x cubed minus y to the 5 equal to 2 cubed minus 2 to the 5, which is equal to 8 minus 32. That's equal to minus 24, and minus 24 is 0 in mod 3. And right-hand side, we have x plus y squared. That means we have 2 plus 2 squared, which is equal to 16, which is not equal to 0 in mod 3, right? Now the next case to consider is if x is not equal to y in mod 3. So the right-hand side would read x plus y squared. Well, one possibility is 1 plus 2 squared, which is the same as 2 plus 1 squared, and that's clearly 0 in mod 3. And the left-hand side, if you're looking at 1, 2, we will have 1 cubed minus 2 to the 5, which is equal to 1 minus 32, equal to minus 31, which is not equal to 0 in mod 3, since 31 is not divisible by 3. If you consider the other possibility, 2, 1, that would be, we have 2 cubed minus 1 to the 5, which is equal to 7, which is not equal to 0 in mod 3. Now, if x is 3, then 3 cubed, which is 27, minus y to the 5 is equal to 3 plus y squared. Well, this is squaring a real number, so that will be greater than 0. That implies y to the 5 is less than 27, which is impossible because y is a prime number. Now, if y is equal to 3, that implies we will have x cubed minus 3 to the 5, which is 243. That's equal to x plus y squared. Now, if we expand this, we have x cubed minus 243 is equal to x squared plus 6x plus 9. That implies we have x cubed minus x squared minus 6x minus 252 is equal to 0. We can rewrite it as x cubed minus x squared minus 6x. Instead of 252, we write it as 36 times 7. That's equal to 0. Now, if we want to factorize this, so it will be some x into x squared, because we want to get x cubed, and we want last term to be 36 times 7. So 7 times 36 would go there. That's x squared here. Now, we want either 36 or 7 to be a negative number because it's minus 252, right? And we also need to consider that we want minus x squared. So we already have 7x squared here. To get minus x squared, we need 6x squared. So if we put plus 6x here, that would give us 6x squared, right? So we want minus 7x squared plus 6x squared. So minus there, plus there. Right? That will factorize the cubic. Now, if you notice that this will have no real solution, so the only possibility is that x is equal to 7. So in other words, 7 and 3 are the only possible solution to this equation. Just to see, the left-hand side was x cubed minus y to the 5, so that's equal to 7 cubed minus 3 to the 5. Well, 7 cubed is 343, and 3 to the 5 is 243, which gives us 100. And the right-hand side is x plus y squared, so it's 7 plus 3 squared, which is equal to 100. So it solves the question. Okay, right? Well, I hope you found it challenging and you found it interesting and inspiring. So thank you very much for joining. So I look forward to seeing you in my future videos. Thank you.